Generations of computers. Analytical engine created a base for the development of modern computer. The computer that we use today was not built in a day. It has gone through different stages of development during past several decades. Computers can be classified into different generations based on the specific technologies used to build them. Let us discuss the characteristics of each generation. First generation computers, 1940 to 1958. Following were the characteristics of first generation computers. They used vacuum tubes. They used punched card for input and output. They calculated data in milliseconds. They were very large in size but had small internal storage capacity. Their programming speed was very slow. They were expensive and consumed a large amount of energy. Examples: Mark 1, ENIAC, EDSAC, EDVAC, and UNIVAC. Let us read about first generation computers in detail. Mark 1. In 1944, Howard H. Aiken designed the first fully automatic calculator called Mark 1. It was about 15 meters long. The machine was slow and took 3 to 5 seconds for each calculation. ENIAC. In 1946, J.P. Eckert and J.W. Mauchly developed the first electronic computer called ENIAC, Electronic Numerical Integrator and Computer, to solve computing-related problems. EDSAC, Electronic Delay Storage Automatic Calculator. The EDSAC was designed by Professor M. Wilkes of Cambridge University, England, in the year 1949. It was slightly faster than the ENIAC. It weighed approximately 6,000 kilograms and occupied an area of 20 square meters. It was the first electronic computer that used stored programs. EDVAC, Electronic Discrete Variable Automatic Computer. The EDVAC was proposed by John P. Eckert and John W. Mauchly in 1944 when the ENIAC was being developed. John von Neumann, who also gave the concept of stored programs, joined them later to help in designing the EDVAC. It was finally completed in 1948. The EDVAC weighed approximately 8,000 kilograms and covered an area of 45.5 square meters. It had capacity to hold stored programs as well as data. UNIVAC. J.P. Eckert and J.W. Mauchly developed another computer, UNIVAC, Universal Automatic Computer, in 1951. It was the first commercially available electronic computer. Weighing around 13,000 kilograms, it covered 35.5 square meter area. It was the first computer to handle both numeric and text data. Second generation computers, 1959 to 1963. Transistor. They used transistors instead of vacuum tubes. They used punched cards and magnetic tapes for input and output. They were faster, cheaper, smaller, and more efficient than the first generation computers. They could calculate data in microseconds. They were costly and could be used only for specific purposes. Examples: RCA 501, IBM 1401. Third generation computers, 1964 to 1970. They used integrated circuits, ICs, in place of transistors. An IC is also called a semiconductor chip and may contain thousands of transistors. They used a keyboard for input and a monitor for output. They used an operating system to run different programs at the same time. They were smaller, faster, cheaper, and more efficient than early computers. Hence, they were made available for general public. Examples: IBM 360, IBM 370, Apple I, ICL 1900. Fourth generation computers, 1971, present. They use microprocessors. Microprocessors are very large-scale integrated circuits, VLSICs, which contain many ICs on a single chip. They use keyboard, mouse, scanner, and so on for input, and monitor, printer, speakers, and so on for output. They are more powerful and reliable than previous generations. They have high storage capacity. They are much smaller, faster, and cheapest among all previous generations. Examples: IBM PC, Apple Macintosh, HP 9000. Fifth generation computers, future. Computers with artificial intelligence are put in the fifth generation computers. These computers are expected to come in near future with the following characteristics. Artificial intelligence, a technology that makes a computer able to think like humans and perform human-like tasks such as voice recognition, decision-making, and translate between languages. Use of super large-scale integrated chips. Ability to recognize image and voice and react accordingly. Ability to solve complex problems including decision-making and logical reasoning.